In this episode, we bring together many themes you have learned so far, like evidence, integrity, change discipline, and monitoring, and we apply them to a very practical question. How do you know when something important has changed without permission? Critical files include the configuration files that define how systems behave, the scripts that automate administrative work, the application components that run payment workflows, and the policy files that control access and security settings. Unauthorized change can be malicious, like an attacker altering a configuration to create a hidden backdoor, or it can be accidental, like someone making a quick fix and forgetting to document it. But either way, the result is the same. The system is no longer in a known, trusted state. Detecting unauthorized change automatically means you do not rely on someone noticing a subtle difference, and you do not rely on memory about what the file used to look like. Instead, you use systematic methods to watch for changes, verify integrity, and alert when the change does not match what is expected. By the end, you should be able to explain what file integrity really means, why monitoring change is a core control in payment environments, and how automatic detection supports both security response and credible audit trails. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good place to start is clarifying why files matter so much, because beginners sometimes assume security is mostly about network boundaries and user logins. In reality, many of the most important security decisions are written down in files, such as firewall rules, application configuration settings, access control policies, and system startup scripts. If an attacker can change those files, they can change the rules of the environment, often without needing to exploit complex vulnerabilities again. For example, an attacker might add a new administrator account by altering a configuration, disable logging by changing a settings file, or create a persistent scheduled action by modifying a script. Even well-intentioned changes can be dangerous if they are undocumented, because they can weaken controls without anyone realizing it. Beginners should notice that files are also easy to copy and alter, and that many systems treat configuration files as trusted instructions, meaning changes are executed automatically as part of normal operation. This is why file integrity is a security concept. It is about being confident that the instructions and components that run your environment are the ones you intended. When you cannot trust critical files, you cannot fully trust the system, because the system is literally following whatever those files say. Detecting unauthorized change automatically depends on the concept of a baseline, which is a known good reference state. A baseline might be the approved configuration for a server, the expected version of an application component, or the authorized set of rules for a payment system. Beginners should understand that without a baseline, you cannot confidently say whether a change is unauthorized, because you have nothing to compare against. The baseline is not simply whatever is there today, because today's state could already be compromised or drifted. Instead, a baseline is created through controlled processes, like secure deployment and approved change management, and then it becomes the reference point for integrity checking. Baselines also need to be updated when authorized changes occur, because the goal is not to freeze systems forever, but to ensure that change is deliberate and recorded. When you have a baseline, you can treat unexpected differences as signals, and those signals are the foundation of automated detection. Baseline thinking connects directly to disciplined workflows, because the baseline is only meaningful when the organization controls how it changes. File integrity monitoring relies on comparing current file state to expected state in a way that is resistant to tampering. Beginners can think of this as checking whether the contents of a file still match what they were when you last approved them, and if not, recording the difference and alerting. One common method is using cryptographic hashes, which are fingerprints of file contents that change when the file changes. The important high-level point is that a fingerprint is more reliable than a casual visual inspection, because it can detect tiny changes and it can be automated at scale. Another method involves monitoring file system events, where the system records when files are created, modified, deleted, or permissions change. Event monitoring can provide timeliness, telling you quickly that something changed, while hash-based validation provides strong evidence that content's changed. Beginners should understand that both approaches are often used together because they complement each other. Events tell you something happened, and hashes help prove what changed. Automatic detection works best when it is designed so that attackers cannot easily change a file and then erase the evidence of the change. Critical file selection is a practical challenge because not every file deserves the same level of monitoring, and monitoring everything can create noise. Beginners should notice that the most important files are those that affect security posture, access control, payment processing behavior, and the integrity of logging and monitoring systems. Configuration files for authentication, authorization, network rules, and logging are high priority because changes there can weaken multiple controls at once. Application binaries and scripts are also high priority because they define what code executes, and attackers often modify them to create persistence or to change behavior in subtle ways. System startup configurations, scheduled task definitions, and security policy files are similarly important because they control what runs automatically and what is allowed. Choosing critical files requires understanding the environment, but the beginner-friendly principle is to monitor what controls trust and what controls access. When you focus on the files that define security boundaries and sensitive workflows, your monitoring is more likely to detect meaningful risk rather than generating constant alerts about harmless changes. Automatic detection also needs to understand what authorized change looks like, because without that context, every legitimate update becomes an alert storm. This is where change management and file integrity monitoring must cooperate rather than compete. When an authorized change is planned, the monitoring system should expect it, and after the change is validated, the baseline should be updated to reflect the new approved state. Beginners should understand that this does not mean disabling monitoring for convenience. It means integrating monitoring into the workflow so that authorized changes are visible, verified, and recorded. Unauthorized change detection is strongest when authorized change is disciplined, because disciplined change creates predictable windows and documented approvals that can be correlated with alerts. If a file changes outside of an approved window or without a change record, the alert becomes more meaningful. When the workflow is clear, responders can quickly distinguish between expected maintenance and unexpected tampering, which reduces both noise and response time. Alert quality matters here in the same way it matters for other monitoring, because a constant stream of vague file change alerts will be ignored. A good alert should tell you what changed, where it changed, when it changed, and why the system believes it is suspicious, such as being outside an approved change window or affecting a high-risk file. Beginners should see that the alert should also include enough context to guide next steps, like identifying the system owner and whether related security events occurred nearby in time. If an alert says a critical configuration changed at 3 a.m., and there were also unusual logins around that time, the combined story becomes more concerning. Actionable alerts also reduce the temptation to disable monitoring, because people trust alerts that help them work rather than punish them with noise. Tuning is therefore part of file integrity monitoring, because you may need to adjust which files are monitored, what thresholds trigger alerts, and how maintenance windows are defined. When tuning is careful, the monitoring becomes a reliable early warning system rather than a constant distraction. A major reason file integrity monitoring matters in payment environments is that it supports credible audit trails and forensic evidence. If you discover an incident, one of the first questions is often whether systems were modified and how long those modifications persisted. Automatic detection can provide timestamps and records that show when a file changed, which helps establish a timeline and helps determine scope. Beginners should understand that attackers often modify files to hide their presence, such as altering logs, disabling monitoring agents, or adding persistence mechanisms. If file integrity monitoring is in place and protected, it becomes harder for an attacker to make such changes without being noticed. It also provides evidence that can be used to support remediation decisions, like rebuilding a system if integrity cannot be trusted. In environments where compliance and evidence matter, being able to demonstrate that critical files are monitored and that unauthorized changes are detected strengthens trust in the overall security program. This is not about catching someone doing something wrong. It is about maintaining proof that the system remained in an approved state. Protection of the monitoring system itself is essential because attackers who understand file integrity monitoring will often try to disable it first. Beginners should connect this to earlier discussions about protecting logging and monitoring, because sensors are only useful if they remain active and trustworthy. File integrity monitoring data should be centralized and access controlled, and it should be designed so that local attackers cannot easily erase or rewrite it. Monitoring agents and configuration should be hardened, and administrative access to monitoring controls should be restricted and logged. Another important idea is monitoring the monitor, meaning you should detect when the monitoring system stops reporting or when its configuration changes unexpectedly. If critical systems go silent, that silence can be a signal of compromise or failure. When the monitoring system is protected, file integrity alerts become credible evidence rather than a fragile local record that an attacker can wipe clean. Automatic detection also supports resilience by catching accidental drift and misconfiguration, which are common even without attackers. A well-intentioned administrator might adjust a setting to fix a problem and forget to revert it, creating long-term exposure that would not be found until much later. A deployment script might apply a configuration incorrectly, causing a system to diverge from baseline in a way that weakens security. Beginners should understand that file integrity monitoring helps here because it provides an early signal that something changed outside the intended process. This early signal allows teams to correct issues quickly, reducing the time the system spends in a risky state. It also supports learning, because repeated drift signals can reveal weaknesses in change workflows, training, or tooling. In this sense, file integrity monitoring is not only a security control against attackers, it is a quality control mechanism that keeps systems aligned with intended secure design. The more consistently it is used, the more stable and trustworthy the environment becomes. As we close, detecting unauthorized change across critical files automatically is about preserving trust in system state through evidence, speed, and disciplined integration with change management. Critical files are the instructions and components that define security boundaries, payment workflows, and monitoring behavior, so unauthorized changes there can quickly undermine protections. Baselines provide the reference point, and integrity checking methods like cryptographic fingerprints and file event monitoring provide the mechanism for noticing differences reliably. Effective programs select critical files thoughtfully, integrate monitoring with authorized change workflows, and tune alerts so they are actionable rather than noisy. Protecting the monitoring system and centralizing evidence ensure attackers cannot easily erase their tracks and defenders can build credible timelines when incidents occur. Just as important, automatic detection catches accidental drift early, keeping systems closer to their intended secure configuration over time. When file integrity monitoring is treated as a living control that supports both security and operational discipline, it becomes one of the most practical ways to maintain trustworthy payment environments day after day.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.